So we talked about surface area. That's just the area of all the sides. Sometimes we want to talk about, and I take out highlighters because I like to highlight my definitions. The lateral area is the surface area without the base. Sometimes you have a shape, you want to paint it. Let's say I want to paint this, but it's attached to my desk. If I'm going to paint it, does it make sense that I don't have to paint the bottom? So then I would only be considered with about the lateral area, which is the area of all the sides except for the bottom. So again, definitions are important. Because if a question says, find the surface area, then you need to know that you're finding all of the sides. If a question says, find the lateral area, and you put up your hand during a quiz and say, what's lateral area again? That I can't help you at that time. I can help you now. I can say, these are definitions that are going to be important, but then you're expected when you get to a quiz or a test to know what they mean. Here's a right pyramid. Has the base that it's a polygon, and then all of the triangular faces that point up to the apex are all going to be the same, where the apex is perfectly right in the center of the shape at the bottom. We have two different kinds of heights with pyramids. We have the actual height, which goes from the apex right down to the center, and we have a slant height, which is measuring the height along one of the side triangles. In surface area, you need the slant height to figure out the area of the triangle, not the actual height. This is going to be the first little tricky thing that you've got to pay attention to, because there's two different heights. And if you plug the wrong height into the formula, it will give you the wrong answer. Kind of makes sense. You plug in a wrong number, it'll give you the wrong answer. So we need to be careful on which height that we're doing. So there's another definition. Again, if you like highlighting definitions, I bolded them for you in your notes, but we can highlight them as well. So when we talk about a regular pyramid, that would mean all of the shapes and all of the sides are the same. This fancy name is a tetrahedron. See, oh, I have one. I have.
Oh, I thought you were actually trying to figure out.
A die that's a tetrahedron. I don't know what game this is from. And I don't know how rolling it actually helps you. It's like, ooh, pointed side up. Try again. Oh, pointed side up again. I don't know if it's ever going to change to something else. I mean, there's numbers, so there's like weird numbers on the side, so I don't know what game this was from. But this is a tetrahedron. All the sides are exactly the same. And so if we wanted to figure out the surface area, does it make sense that the idea would be you have four triangles all the same? Do we know things about this? Yes, we know that the base is 5 and the height, which is the slant height of that triangle, is 4.3. The area of one of these all right. Double double check it. Yes. So the surface area will be 4 times 21.5. Something else that's nice on lots of calculators. So if I do 4.3 times 5, I get an answer. Then if I want to multiply that by 4, I can just hit the multiplication button. Automatically brings up the answer from before, times it by 4, and I get 86. I look for my units. We were dealing in meters, so this becomes meters squared. Just thinking if we have, this next question is kind of involved. You have a picture given to you, but there is a lot of information going. So I think we're going to leave this one for tomorrow. But I'm going to show you a formula for your textbook that isn't on your formula sheet. Okay? So if you want to use this formula and it's not on your formula sheet, then you would have to figure it, like either memorize it to use it. Okay? It's kind of cool, but I think the easier formula is just to break it up, right? If we have a shape that we want to find the surface area of, you just need to break up all the shapes that you have. So on this pyramid, I have a hexagon on the bottom, which you don't know how to find the area of a hexagon. We're not going to worry about that right now. But part of the formula is you would have to find the area of that bottom shape. So they would either give you a hexagon formula for that specific question or give you a strategy to figure it out. Then, normally what I would just do is say, hey, we have 1, 2, 3, 4, 5, 6 triangles. Find one of those triangles and times it by 6. That would be perfectly fine. If I found one of those triangles, it would have a base and a height, and you would do base times height divided by 2. And the next triangle would have a base and a height, and you would do base times height divided by 2. What they're saying here is that if you would like to, you could just add up all of the bases together first and get the perimeter. Then you could times by your height and divide by 2. Logically, I think it's easier for our brains just to do the 6 different shapes on their own. But here's another formula that was in your formula sheet so that I would show it to you as well. Okay, so we'll show how you would use that formula in that next question. Again, we'll leave the other one for you for later, for tomorrow. But if we wanted to figure out the lateral area, so again here it's important to see that this question saves us that we don't need to know what a hexagon is. We just have to figure out the lateral area. Then going to our formula, which is right here, the surface area will equal 1/2 the slant height times the perimeter. And we don't have to add the base, right? Because it's a lateral area. So then in our question, the surface area will just be 1/2. The slant height is given to be 12. And if one side is 5, then the perimeter of a hexagon with 6 sides would be 30. Multiply that out, include our units, and we would have 180 centimeters squared.